This was the omitted portion, oxygen and compounds of oxygen. First, we should study dioxygen. Dioxygen means O2. Why is it called as dioxygen? Because the formula is O2, so it is called as dioxygen. Preparation of dioxygen. Laboratory methods. First, by heating chlorates, nitrates and permanganates. Twice KClO3 gives twice KCl plus 3O2. KClO3 is potassium chlorate which decomposes in presence of MnO2 which acts as a catalyst when it is heated. In presence of catalyst, the reaction is faster and it gives oxygen very uh, quickly. Second is by thermal decomposition of oxides of metals. Silver oxide, mercuric oxide and lead dioxide. These are the oxides of metals which we heat to get oxygen. They decompose into metal and oxygen in case of silver oxide and mercuric oxide. In case of lead dioxide, it decomposes to PbO, which is lead monoxide or litharge plus O2. Third method, by decomposition of H2O2. You know H2O2 releases oxygen continuously. In presence of MnO2, when it is heated, we get oxygen very fast. You know electrolysis of water, acidulated water. So I have written H plus. Acidulated water when electrolyzed gives hydrogen at cathode and oxygen at an anode. Industrial method is from air. From air, carbon dioxide and water vapor are removed first, then remaining gases are liquefied, and then by fractional distillation we get dioxygen. So these are the methods of preparation of dioxygen. Now let's study physical and chemical properties of dioxygen. Physical properties of oxygen: it is a colorless, odorless gas, sparingly soluble in water, about 30.8 cubic centimeter, dissolve in 1000 cubic centimeter at 293 Kelvin. It is sufficient for marine life or aquatic life to sustain. Liquefies at 90 Kelvin, freezes at 55 Kelvin. Stable isotopes are O16, O17 and O18. Molecular oxygen exhibits paramagnetism. Now chemical properties, they are very simple. Reaction with metals, except gold and platinum, it reacts with metals to form oxides. So you can see that with calcium it forms calcium oxide, with aluminium it forms aluminium oxide. Reaction with non-metals, except noble gases, it reacts with non-metals also to form their respective oxides. So with carbon it forms carbon dioxide, carbon monoxide. With phosphorus it forms phosphorus pentaoxide. Reaction with some compounds. With zinc sulfide it forms zinc oxide and sulfur dioxide. With methane it forms carbon dioxide and water. With sulfur dioxide it forms sulfur trioxide, and with HCl it forms chlorine and water. The reactions are these. Uses: it is used for respiration by all animals, organisms, aquatic or even terrestrial. It is used in manufacture of steel. Oxyacetylene flame is used for cutting and welding of metals. Oxygen cylinders are used in hospitals or in mountaineering. Combustion of fuels, this is very necessary for combustion of fuels. For example, in rockets, hydrazine in liquid oxygen provides a tremendous thrust. So these are the uses of. They often ask, dioxygen is paramagnetic, explain. It can be explained on the basis of molecular orbital theory. Electronic configuration of oxygen is Kk. Kk means sigma 1s2, sigma asterisk 1s2, sigma 2s2, sigma asterisk 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi asterisk 2px1 and pi asterisk 2py1. Due to the presence of unpaired electrons in these orbitals, oxygen shows paramagnetic nature. Now, simple oxides. Oxides are the binary compounds of oxygen and any other element. There are different types of oxides. First ones are acidic oxides. They dissolve in water to give acid and react with bases to form salts. Generally, non-metallic oxides are acidic in nature. For example, SO2, SO3, carbon dioxide, nitrogen oxide, chlorine oxide, they are all acidic oxides. You can see from the reactions that SO2 reacts with water to form sulfurous acid, or SO2 reacts with sodium hydroxide to form a salt, sodium sulfate, along with water. Basic oxides dissolve in water to form bases, and they react with acids to form salts. Generally, metallic oxides are basic oxides. For example, sodium oxide, calcium oxide, or barium oxide. Amphoteric oxides react with acids as well as bases to give salts. You can see that aluminum oxide reacts with NaOH in presence of water to form this salt. It is a complex salt which we will study in coordination compounds. It reacts with HCl also to form a complex ion, that means salt only. So aluminum oxide is an amphoteric oxide which reacts with acids as well as bases to form salt. Neutral oxides are neither acidic nor basic. Examples are carbon monoxide, nitrogen oxide, that is nitric oxide, and nitrous oxide. Second compound of oxygen is ozone. Ozone is formed in atmosphere in ultraviolet light. In presence of ultraviolet light, oxygen decomposes to form two oxygen atoms, and then oxygen reacts with one of these oxygen atoms formed to form ozone, that is O3. In lab also we can prepare ozone, preparation of ozone. I have by mistake I have written O2. O3. In lab, uh, ozone is prepared in an apparatus which is called as ozonizer, where silent electric discharge is passed through oxygen when oxygen converts into ozone. But as only 10% conversion occurs in this case, uh, the ozone so formed is called as ozonide oxygen, and this reaction is endothermic. You can see that delta H is positive in this case. Physical properties: in gaseous form it is pale blue, in liquid form it is dark blue, and in solid form it is violet black. It has a characteristic smell, and if it is inhaled, uh, even in a concentration 100 parts per million, it causes nausea and headache. It is diamagnetic in nature. Chemical properties of ozone. Ozone acts as oxidizing as well as reducing agent. Oxidizing agent because it decomposes it to give nascent oxygen. It oxidizes lead sulfide to lead sulfate, potassium iodide to iodine, and NO to NO2. NO emitted from jet aeroplanes causes depletion of ozone in the upper layer of atmosphere. Reducing property: it reduces hydrogen peroxide and barium oxide, barium dioxide to barium monoxide. You can see that H2O2 converts into H2O and BaO2 converts into BaO. Due to nascent oxygen, it acts as a bleaching agent. Nascent oxygen reacts with colored matter to turn it colorless. Ozone depletion. We have seen that ozone is formed in the atmosphere due to ultraviolet rays of sun, but because of nitric oxide, ozone layer gets depleted. It also gets depleted by chlorofluorocarbons emitted from refrigerators or air conditioners. Ozone depletion is most pronounced in polar regions. It causes skin cancer, eye cataracts, and it causes damage to our immune system. Structure of ozone. Ozone is a resonance hybrid of these two structures. The oxygen-oxygen bond length is 128 picometer and the angle is 117 degree. Uses of oxygen. Ozone is used for air purification in crowded places like cinema halls, tunnels, railways, etc. It is also used in sterilizing drinking water by killing germs and bacteria. For, third use, for bleaching ivory, starch, wax, and delicate fabrics like silk. And fourth, in the manufacture of synthetic camphor, camphor, etc. So these are the uses of ozone.